So in this video, we talk about parallel and perpendicular lines and we compare their slopes. And here you'll see that in our picture we have the graph of two parallel lines. And these are graphs that will have the same slope, but they will have different y-intercepts. And that means that they will never intersect. So let's take a look at these two lines here and let's determine the slope and y-intercept of each. I'll call this line 1 and this one line 2. Line 1 has a y-intercept here of 0, 3. And then I'm going to find another point that lies, let's use this point here, it lies very nicely on the crosshairs there. And then let's count the rise. And the rise will be up 2. And then we're going to count the run. And the run will be right 5. So the slope of line 1 is 2/5, rise over run. Now let's look at line number 2, and line number 2 has a y-intercept of 0, -2. And now let's pick this point here, and we will count the rise over run so that we can determine the slope. And notice that we're going to have to go up 2, and that we're going to once again have to go right 5. So these two lines, as you can see, have the same slope but different y-intercepts, and that makes them parallel. They will never intersect. Now, the reason that it is key that the intercepts be different is because if the two intercepts were the same, then you would have the same line, of course. Okay, so those are parallel lines. So again, let's recap what we just discussed. Parallel lines have the same slope and different y-intercepts, and the slopes of parallel lines are equal. Parallel vertical lines have different x-intercepts, so we didn't talk about that, but we'll be looking at that in future problems. Okay, let's talk now about perpendicular line. Now in this graph, I have the graph of two lines. One is the line y equals -4x plus 2, and the second line is the graph of the line y equals 1/4 x minus 1. So the equations are given to us, and these two lines are perpendicular. So that means that they cross, and right where they cross, right here, they are forming 90-degree angle. I want you to look at the relationship between the slopes this time around. Definitely they're not the same, right? As a matter of fact, if you notice, one line will fall, right? So line number 1, if we call this one line number 1, this is a falling line. It's going to fall. And line 1, which is the line y equals -4x plus 2, the slope is -4. Now line number 2, we have the line that's rising, and its equation is y equals 1/4 x minus 1, and then the slope is 1/4. So notice that if you compare the two slopes, we have one line that's going to fall. So you're going to have one line that's negative. Then you have another line that's going to rise. So you have another line that's positive. And how are the numbers 4, which is 4/1, related to the number 1/4? Well, these are reciprocals, aren't they? I'm going to label these slopes M1 and M2 here. So let's look at these slopes again. We have M1, which is the slope -4/1 of our line 1 that falls. And then we have M2, which is the slope +1/4 of our second line, which is rising. And notice that these two slopes are going to be opposite signs. So one will be positive and one will be negative, and they're going to be reciprocals of each other. So in order for two lines to be perpendicular, their slopes are related in this way. One's a positive, one's a negative, and they are reciprocals of each other. So opposite signs, reciprocals. So a little recap of what we've just been discussing is that we have lines that intersect at right angles. We call those lines perpendicular, and that if we look at the slope of the first line and then compare it to the slope of the second line, we can see that they're going to be negative reciprocals of each other. And this is a new idea too, or actually this is another way of saying the same thing, that if we multiply them, their product is -1. So notice that if we multiply the 1/4 times the -4/1 from our two slopes, that those 4's will reduce, right, and give us a -1. So this is the definition of what a perpendicular line is. Perpendicular lines are lines that form right angle, and slopes are negative reciprocals of each other. Product of their slopes is -1. And here's an idea. A vertical line and a horizontal line are always perpendicular to each other. Okay, so now that we know the definitions of parallels and perpendicular lines, let's go look at two lines and compare them. And just by looking at their slopes, let's see if we can decide whether the lines are perpendicular, parallel, or neither. So determine if the lines are parallel, perpendicular, or neither. So look at problem number 1. These two lines are in slope-intercept form. So we can determine their slopes by looking at the equations. And line number 1 has slope of -1/5. And then line number 2 has slope of 5/1, doesn't it? I'll call this m sub 2. So m sub 1, which is the slope of line number 1, that's a -1/5. And m sub 2, which is the slope of our second line, that's a positive 5/1. So what do you notice? Did you notice that they are opposite signs and reciprocals? Yes, so that means that we have here what kind of lines? These are the perpendicular lines. Okay, well done. Let's look at problem number 2 now. And in problem number 2, we have line number 1, which is in slope-intercept form. So we can definitely read this slope from the equation, which is +3/4. But line number 2 is in standard form, isn't it? So we're going to have to do a little bit of work. Let's rewrite line number 2 in slope-intercept form. So we have to solve for y. So that's -3y equals -4x plus 15. And now we're going to divide by -3 everything here. So we get y equals +4/3 x minus 5. The slope of this line, m sub 2, is 4/3. So we have one line with a slope of +3/4 and a second line with a slope of +4/3. And notice that these lines have slopes that are reciprocals of each other, but they're not opposite reciprocals. You see that? The signs are the same. So here you have two lines that are rising. They will eventually meet because they have different slopes. However, they're not going to cross at 90-degree angles. So this is a case where the lines are neither parallel nor perpendicular. So we would say neither. So in this problem, both lines are in standard form, so we have some work to do. Let's take line number 1, and that's -x plus 3y equals 10, and rewrite this in slope-intercept form, which means that we're going to solve for that y value, as you know, and then we're going to read off of that the slope. So here we have y equals x over 3, which is the same thing as 1/3 x plus 10/3. So our slope, m1, will be 1/3. Okay, beautiful. Let's look at second line. That's L2. L2 is 2y plus 16 equals -6x. So we're going to subtract the 16, get 2y equals -6x minus 16, and then we're going to divide by 2. So we'll divide by 2, and we get y equals -3x minus 8. So we have m2, which is a -3/1. And how are these two slopes related? Did you notice that they're opposite signs and reciprocals? So we once again have here perpendicular lines. Well done.